All right, our last round of trig proofs here. There are a few ways we could go with number 19. I don't suggest multiplying by conjugates to begin with because you're not in terms of sine and cosine yet, so sometimes that's not helpful. I'm going to start on the left side, and I'm going to change the tangents to sines over cosines. So sine theta over cosine theta minus 1, and then sine theta over cosine theta plus 1. I'm going to clear out the complex fraction first, so I'm going to multiply by cosine theta over cosine theta, which is legal because you're multiplying the fraction by 1 when you do that, so you're not changing its value. So when you distribute a cosine through, you get sine theta minus cosine theta and sine theta plus cosine theta. And again, you might be tempted to multiply by a conjugate here, but that's just going to give you like a sine squared plus or minus cosine squared combo. So it'll take a lot of work to keep going. So here's a trick that we did when we were coming up with the Pythagorean identities. So let me switch back to our notes, actually. So if we take a look at our notes, remember when we came up with the other two Pythagorean identities, and we said, well, let's divide by cosine squared on both sides, or divide by sine squared on both sides. And the goal in doing that was to force a sine squared into a tangent squared, or a cosine squared into a cotangent squared. So back to our worksheet, I would like to get cotangent. So what do I need to do to make that happen? Well, cotangent is cosine over sine. So what if I say, you can think of this two ways. You could say divide by a sine, or I think we're used to multiplying, right? So I think it's a good idea to say, let's multiply by 1 over sine theta over 1 over sine theta. We don't normally do that. We normally do this just to clear out fractions, but actually I kind of want to create fractions. So let's look at what happens when I do that. So 1 over sine times sine is 1. 1 over sine times negative cosine is minus cosine theta over sine theta. This is a good sign because look at our top, 1 minus cotangent. Something similar happens in the bottom. 1 over sine times sine is 1 plus cosine over sine. Make sure you're writing all of your thetas for all of these trig functions. And that, of course, is equal to 1 minus cotangent theta by our quotient identity over 1 plus cotangent theta. And that's the end of my proof. I could have done the same steps if I started on the right side and sort of done this in reverse. Instead of multiplying by 1 over sine, at some point I would have multiplied by 1 over cosine. All right, let's look at this one. I want to say we had something like this in our notes, if not this same one possibly, but see if you can do it without looking back at the notes. So for this one, you could start on the left side and say, I'm going to multiply by the conjugate right away, or you could work on this side and say, I'm going to make this 1 over sine theta plus cosine theta over sine theta. This is how I did it in the notes. And just kind of following my guidelines, I tend to start on the side that has something to add together. These already have a common denominator. We might not have done this exact one in the notes, but it's quite similar. Okay, so you get stuck right here. You're trying to get sine over 1 minus cosine. So how can you make that happen? Kind of two ways to think of this. You can remember that this is the conjugate trick. We're multiplying by the conjugate of 1 plus cosine, so 1 minus cosine. Or when I multiply by this top and bottom, it puts the thing I want in the denominator in the denominator. Like, that's something that we do in calculus sometimes. I really want this expression in the denominator, so I'm going to go ahead and multiply it in. And I can do that as long as I also multiply it in through the top. So, little calculus skill preview here. So 1 plus sine times 1 minus 1 plus cosine times 1 minus cosine is 1 minus cosine squared theta. And when we did this in the notes, I said a good rule of thumb is to not actually distribute the non-conjugates together. That'll save you some time and some factoring in the end. So leave this as it is. Hopefully by now 1 minus cosine squared is starting to jump out at you as sine squared. If not, to help yourself memorize some of your trig proofs, it's a good idea just to kind of write them out a few times. Make yourself a little chart for the reciprocal, quotient, and Pythagorean and write them out along with their alternate forms. Final thing, sine squared over sine. One set of sines divides out to 1. So we're left with sine theta over 1 minus cosine theta. All right, take a look at 21. The more complicated side is definitely the left side. It's illegal to divide by sine and divide by cosine and call this sine squared plus cosine squared. That's illegal. Plus also, if we did that, we would get 1, and then that's not what we have on the right side. So instead, if you see something to the third power, that's a good hint to factor. This is a sum of 2 cubes. So it's been a while since we had factoring speed quizzes, but hopefully you still remember our SOAP formula. So take the cube root of each term, sine theta plus cosine theta, and then it's the first term squared minus these two multiply together. I'm going to write sine theta, cosine theta. You can see, so we're getting pieces of the right side together. And then plus the second term squared. And all of this is still over sine theta plus cosine theta. Not sure why my pen keeps giving out there. Okay, and then this sine plus cosine can cancel with that one. So that leaves us with sine squared theta minus sine theta cosine theta plus cosine squared theta. Always be on the lookout for Pythagorean identities. So sine squared plus cosine squared is equal to 1. 1, there we go, minus, not 2, minus sine theta cosine theta, which is what we're trying to get on the right side. So we are finished. Okay, this pen of mine is acting up. Let me see if I can recharge it a little bit. All right, so take a look at 22. The left side is more complicated than the right side, and you should notice a trinomial on the numerator of the left side, meaning we want to factor this. Now, if you want to factor a negative out, you can, although take a look over here. Your hint for how to factor this thing is on the right side of the equation. So even though I don't love factoring with the squared term at the end, I'm going to keep it like this just to match this. So how do I break up 1, 1, and 1? How do I break up 3 sine theta? 3 sine squared theta, just as you would for 3x squared. So you need a 3 sine theta somewhere, and you need a 1 sine theta somewhere to multiply to 3 sine squared, just like you would have 3x and x. We're trying to get minus 2 sine in the middle, so we subtract and add. Again, your hint to subtract is here, but also this is minus 3 sine plus 1 sine. So that's going to give us the minus 2 sine that we want. Now it's over cosine squared, but take a look at the denominator here. This has 1 minus sine. So maybe that's a good hint to say cosine squared should probably be rewritten as 1 minus sine squared. Okay. How does that help me? Because if I didn't make that substitution, I wouldn't have anywhere to go. Well, 1 minus sine squared, looking at the 1 plus sign that I have up here, we don't always factor this, but this is a difference of squares. So we could say we've got 1 minus 3 sine theta times 1 plus sine theta. And if we factor the denominator, 1 plus sine theta times 1 minus sine theta, we can cancel the 1 plus sine thetas, and then we have our proof. We're only left with 1 minus 3 sine theta, and in the denominator, we're left with 1 minus sine theta, and that's what the right side of the equation is, so we've proven that. All right, just 2 more problems. So on 23, definitely the left side of the equation is more complicated. There's not really much to do with cosine. So let's start over here. Okay, what are the general guidelines? I look for trig functions. look for trig functions. Okay, trig functions are all over the place. I look for Pythagorean identities. So I see 1 plus tangent squared. So I'm just going to make that change. Cosine squared over secant theta plus tangent squared theta times cosine theta. This is now all over secant squared theta. Okay, now again, I might be doing this differently than I did in my answer key that I posted. Normally, I would change everything to sine and cosine to see what I'm working with. But what about this? I'm noticing that I have a secant and a secant squared, so I could get a common denominator, secant squared theta. So this cosine squared, to get the common denominator, needs to get multiplied by secant theta, just 1, secant theta, not secant squared. So that would be cosine squared times secant theta. And this already has the denominator, so I'm going to write down plus tangent squared cosine theta. So let's see if that helps me at all. My next step would be to change things to sine and cosine. So we've got cosine squared theta times 1 over cosine theta plus sine squared theta over cosine squared theta times cosine theta. All of this is over 1 over cosine squared theta. All right, so a little bit cancels. Cosine and a cosine. So I'm left with cosine theta up there. This cosine in one of these, so plus sine squared theta over cosine theta. Still just over 1 over cosine squared theta. I've got an ugly complex fraction here, so let's multiply by, make sure it's cosine squared. All right, so if I do that, I get, cosine cubed. It's weird. Cosine cubed theta. I'm trying to get just down to cosine. What about here? I get plus sine squared cosine theta, because that cosine cancels with one of those. And then what about in the denominator? 1 over cosine squared times cosine squared is just 1, right? All right, so we didn't need the over 1 there. What can I do here? Well, like I said, if there's a cosine cubed, you probably have to factor something. So there's a GCF I can factor out, cosine theta. And that's going to make this cosine squared plus sine squared. Aha. And that is the Pythagorean identity that's equal to 1. So we get cosine theta. Now, did I take the long way around? Because that's a lot of steps. Possibly. Let's take a look at the key that I posted to see if I did the steps in a different order. Oh, wait, this is way shorter. Okay, so what did I do on 23? Instead of common denominator, on this one, yeah, I rewrote in terms of sine and cosine first. So here's another option. Sine and cosine. I did change 1 plus tangent squared to secant squared. Instead of dividing by secant squared, I showed times cosine squared over 1. So yeah, doing sines and cosines first, changing the divided by secants to times cosine over 1, that made things a little bit faster. And then I got to this, to like a place where I got cosine cubes to cancel instead of having to factor them out. So different approach. This way was more efficient. But what I just did in my video, even though that's a lot of steps, it's really only maybe 3 or 4 steps shorter. These last 2 are barely steps, right? Okay, let's look at 24. So what do I notice about 24? There are cosine to the fourths, which means, and sine to the fourth, which means I'd probably like to factor, but make sure that you're being careful on factoring problems. If the 2 trig functions are different and there's a third term, you're not going to be able to factor like a normal trinomial. Plus, this wouldn't factor anyway. X to the fourth minus y to the fourth minus 1. Nothing works with that. So take a look at the right side. All we're supposed to have on the right side are sine squareds. So let's begin by getting rid of this cosine of the fourth. And how are we going to do that? Remember that cosine of the fourth is cosine squared, right? We don't normally have to write that, but let's just make a note of that because we don't have a formula for cosine of the fourth. It's not equal to 1 minus sine to the fourth, but it is equal to the quantity 1 minus sine squared, that quantity squared, and then the rest of this is just along for the ride. When I square 1 minus sine squared, I get 1 minus 2 sine squared x. That's a good sign. I'm supposed to get that in the end. Plus sine to the fourth, because it's sine squared squared, x. Still have a minus sine to the fourth x, minus 1. So this thing looked like it was going to be ugly, but look at this. You've got a positive 1 and a minus 1. You've got a plus sine to the fourth and a minus. So in just a couple of steps, I got negative 2 sine squared x. All right, so trig proofs take practice. We've seen a lot of different techniques in these 24 proofs, but you've seen a lot of things that are common too. So part of trig proofs is remembering some of the common themes. Go back to the notes. So we have this idea of like, what are some general guidelines? There's not always a nice first step that you always do. There's not always a second step, always a third step. It's sort of like try some of these things. And you can see a few times I solved a proof differently in my video than I did on my answer key when I did it on my own. And both ways would be full credit if we were doing a quiz or a test.